Hello and welcome back to my channel. This is video number 9 and today we will implement Doubly linked list. What is Doubly linked list? A doubly linked list is just a linked list which can traverse backwards. That's the main difference and that's the only difference. Advantages could be that if let's say you have a problem in which you have to access the previous node from a given node, then doubly linked list is the right implementation for that. But apart from that, I don't see any advantages of using doubly linked list over linked list. However, there are many disadvantages. Some of the disadvantages that I can think of just the top of my head are you will have to carry one extra space for your previous pointer. Now each node will have two pointers, one to point forward, one to point backwards. So it will require more space. The other disadvantage is that now the deletion is a bit more tricky. Now you have to manipulate two pointers instead of one. So when you have to remove a node from between in doubly linked list, you have to set the previous pointer of the node which comes after the deleted node to the one which comes before the deleted node. And likewise, you have to do it for the node that comes before the deleted node. So you see, like, deletion process is more complicated in doubly linked list, but it really depends. Like if you have to implement an algorithm that requires you to go backwards from a certain point, then doubly linked list could be a very good data structure to implement that. Let's head back to the IDE and implement doubly linked list. See you there. Today we'll create doubly linked list. So for that I create a package. So let's call it D linked list, D for double. And inside this, I'll create a class doubly linked list. In doubly linked list, we need a new node that will contain the pointer to the next node and the pointer to the previous node. So I'll just go ahead and create another class and let's call it D node. It will be of type T. It will have a previous pointer. It will have some data and it will have a forward pointer or the next pointer. This will point to the next node. And I'm using @value annotation here, which is from Lombok. By using @value from Lombok, it creates the D node as an immutable object. It will only allow the properties to be set at the time of creation via constructor, and you cannot modify the properties later on. Cool. Let's head back to our doubly linked list class. This will be a generic class, so the person who is creating this object can state that what type of object it should hold at any point of time. So in this current example, we'll hold integer. That is what we have been doing, but you can hold any other object like string or any custom object type as well. We'll create a test class. So first test case. Now with doubly linked list, you have a benefit of adding the node at the end of the list, or you can add node in the front of the list. Likewise, we'll do that. Public void, it should append the item at the end of the list. Add to last. Then we need to provide a value. Let's say add number 100. I'm going to assert on the size of the list. So as soon as I say add one item to the list, its size should grow by 1. And that is what I'm asserting on. I'll create this method. Now if size is 0, then I can simply create a new object and assign it to the last one. So the previous pointer at this point will be null because this is the first node. The next pointer will be null and the data will be the one that is passed by the user. Now this node needs to be added to the last of the list. Now I'll create those. These are the placeholders, and this will always point to the first node, and this one will always point to the last node. In the entire life cycle of this, you have to write a code in a way that it will always point to the last node and the first node. In this scenario, when our list is empty, our first node will become the last node and first node as well. So in both the scenario, we have the same. And when our list is not empty, then we want this node to point to some place. So what we'll do is we'll set the last node pointer. So we created D node as immutable objects, but now I realize that we'll have to modify it. So let's make it data. And I want all args constructor. I also have to set the previous pointer for the new node so that it should point to last node. At this point, last node is the last node, right? Because there's no node after last node. So I'll take the new node and I'll set its previous pointer to what was the last node in my list. Then I will set the next pointer in this last node to be this one. That is what I did there. And then the last node will become the new node, because we are always maintaining the pointer to the last. So this is the functionality for add to last. Very important, the size should always increment. By default it will be 0, and once this is successful, I want to increment the size by 1. Now head back to our test case and see if that is the case. Okay, I also have to create the method size that will return the size of the list. Let's see if it works. So this will add the given node to the end of the list. Now I will write the test case to append at the front of the list. And I'll also use add to last 100. We can keep this order, and the size will be 2 now because we are adding 2 objects. So the logic is pretty much the same for adding the node, first node here. So I'll just copy this part, and then we can do the refactoring later as well. So as usual, if I have the data, I have to create a new node because we have to add it to the list. So I'll just create this node here. Then I'll check if size is 0. The person can call add to front when the size is 0. Then we have to make sure that our last node and first node is the new node that the user has passed. Else, if the size is not 0, here instead of adding it to the last node, we'll add it to the first node. So this new node is the first node. So first node should always point to the previous first node, right? So if I'm adding a new node in front of the list, so I should take this new node and set the next pointer on this to point to the first node in the list. So that is what I did. So I took this new node and I'm pointing it to the first node that I have. And now my first node will point to this new node point backward to the new node. And then at last, the first node will become the new node. And this will increment the size by 1. We can extract it out later because this is same as this, I think. Or let's see how IDE does that. Cool, so it extracted out the common part. Let's see if our test case is working as expected. Now at this point, if you look at the test case, it is not complete. It doesn't give us the exact scenario of what is happening because we don't know if it added in front or it added it last. So we have to make sure that it works the way we want it to work. So this is the first node of the linked list, and we know that if we are adding it to the front, this front node should always be the one that we add here, which is 99. So we'll create another assert statement for that. And I'll create this method. And now let's see if it works. Awesome. This means that we have verified both the scenarios. So both the elements are getting added to the list, and our add to front functionality is working fine because in the front we get the correct data. And we can also add one more assert statement just to be sure that the value 100 is being added to the next of the node, and we are not breaking the chain here. So now we are sure that everything is working as expected by these 3 assert statements, and we can also break it or comment it into given, when, then. So this is what we follow. So next we want to get an item which is one previous to the given node. We'll pass the value and we'll fetch the previous node from that value. So this is really easy in Doubly linked list because we have the previous pointer at every node. So let's see how can we do that. I passed the value 100 and I want it to return the one node that is before 100, and it will give me the value 99. So I'll create this previous method. So here I'll have to search the entire linked list to find that data. But once I find that particular node, returning the previous node is really easy. So let's iterate over that. Now we can traverse it from backward or we can traverse it from front. So it's up to us from where we want to travel. So in this case, I'll travel from the front. I'll take the first node and put it in the temp variable. So here I'll set temp to the first node, then I'll iterate over that till the condition where I reach the end of the list. So if I reach the end of the list, then my temp will be null, then it won't go inside this loop and the default value will be returned. But if we find the value in the list, then I'll return the previous node to that particular node, and that's how it will be done. So let's check if it is working as we expected. Correct. So it is working as we expected. This is the thing that you can do with Doubly linked list. You can return the node which is previous to the given node. So this is very handy operation. So if you are working in a scenario where you need to access the previous nodes, then Doubly linked list is a perfect implementation for that. Moving on, now we want to remove a node from the list. I'll make it common because I'm using it everywhere. Then my other test cases will become very clean. I don't have to make use of this everywhere. Yeah. Now I'll remove the value 99 from the list. So I'll only have one item with value 100. So that is what I'm going to assert. This is what I have now in my list. So if I call front, it will only have one item and that should point to the front object, and the value of that object should be 100. Now we have to iterate over the list, find the item, and then set the pointers for the previous and after nodes of that node. To iterate to that item, I'll use the same logic that I used here. I'll just copy paste the code. So now I have this temp. So if I find this item here, this is where I have to write some logic to make that manipulation. I just assign these values here to make it more readable. So what I'm doing here is that I got the node that I have to delete, which is the temporary node, that the node I find here. Now I access the node which comes before this node, and then I access the node that comes after that node. Now I'm setting the previous node's next pointer to node after, and node after's previous pointer to node previous. I hope this will make it easy. So now I'm just eliminating the middle link that we want to delete. I'm just setting the pointers for previous and after nodes to each other. That is what I'm doing here. And if this is done, I want to break the loop. Makes sense, right? Now let's see if that is the case. But here there's one situation that can happen, and this is the one that I was thinking about. We can get null pointer. What if the node is the first node that we're trying to delete, which is the test case here? And I only have two nodes, but I'm trying to delete the front node, and front node doesn't have any node that is previous or prior to it. So in that case, I'll get the null pointer exception, and that is what I'm getting here, because I do not have any previous node. So previous node is null. So we know that this is the first node. So instead of temp, I can say first node here, and I want to delete the first node. So all I have to do is make my first node get next and set it to first node. This will delete it, and then I don't have to do anything here. I'll just remove. So this will resolve this error, I guess. Yes, but this is again incomplete. What if we are to delete the last node and there's no after to that node? So we'll have to work on that as well here. So last node dot get data equals item. Now this will delete the front node as well as the last node. So even if I pass the node which is the first one, it will remove that, and even if I pass the node which is last one, it will remove that. So let's see if I copy this statement here and delete 100, then I should get null, because my front is null, so it will throw null pointer exception here, but this will be null. Awesome. So this is working as expected, but I'll keep it till here. I won't complicate it. I think we're done with the doubly linked list, and this is how we can iterate it. We have appended it to the last, we have appended to the front, and we have removed it. Here we did the linked list traversal as well, starting from first node. If you want to start from the last node, you can just set this to last node, and instead of get next, here we'll say get previous, and that is the only change that will be there. So let me know in the comments below if you want to add something to it, or if you feel like I have missed some point or I've done it differently, then do let me know in the comments below. So what are we going to do in the next video? Next video we will implement ArrayList. See you there. Bye bye.